Hello and welcome to Math 253 Calculus 3 here at Cañada College. My name is Lapuz. In this video we are looking at a homework problem from section 5.3 where they ask us to evaluate an integral over the region D, and the integral is going to be 7 times r cosine theta r dr d theta, where the domain is going to be an r value or set of r values going from 0 to 2 plus sine theta, and our theta goes from 0 to pi over 2. All right, so I had this set up a little bit ahead of time because it might be kind of difficult. And what we can realize is that the function, the integrand, is 7 times r cosine theta, and then the r dr d theta is dA. R cosine theta is just x, if you remember. So I was able to graph that as 7x. And then the dA, r dr d theta, will just be equal to dA. And then I was able to write down a polar coordinate representation of the domain, and that is the r value going from 0 to 2 plus sine theta. Now 2 plus sine theta is close to, but not exactly, close to cardioid. And our limits for theta goes from 0 to 2 pi. So if we expand this a little bit and take a look at that shape, if we go, the problem isn't asking us to do this, but if we go from 0 to 2 pi, this almost looks like a cardioid, not looking at the three-dimensional picture, but the two-dimensional picture. And if you make this into 1, then it actually does become that cardioid shape. And now the z is equal to 7x. If we were to just graph that real quick, that's going to be a plane that cuts through here. So if we were to go all the way from 0 to 2 pi, this thing, because of the symmetry about the y-axis, the polar axis, we would get 0. But a few things change. We're going from r goes from 0 to 2 plus sine theta, and here we're only going to go to pi over 2 instead of going all around to 2 pi. And we don't need to take a look at that big plane. So this is just the piece of the graph that we're looking at, and we're essentially finding the volume of this. All right. I think our integral is pretty much set up for us. If we take a look at this, it's already in polar coordinates and we have the limits, so we simply have to put that into our integrator. You can actually integrate this by hand, of course, but if we throw this in the calculator, it'll be a double integral. So it's going to be integral from 0 to pi over 2, and then another integral on the inside from 0 to, this time it's 2 plus sine of theta. And then so we can't break this apart like we might have been doing in some of the examples that we've done before, because the limits are not constant. So we have an r times cosine of theta, and then we have an r, and then dr, and then d theta. All right, so this is our value. Again, this should be manageable using doing the integral by hand. I don't think there are any fancy integrating tricks to do this, but if you're used to just getting stuff from the calculator, that should be good. All right, I hope that helps. Good luck.